Okay guys, we're going to do about 4 examples that are a little bit more challenging so that you can get used to seeing how to do this. We're going to blend rules. We're not going to just stick to one rule anymore. So you need to know how your rules 1 to 5 apply here, and rewatch this video over and over so that you get used to these items. Now remember, what do we see here? We see 1, 2, 3, 4 terms. And these terms, some of them have variables and some of them don't. If we have a constant, we know that if we differentiate that constant ends up falling away because it becomes 0. And if we have to add and subtract our different functions or our different variables, we know we've got to apply the derivative rule to each one individually. So if I'm going to apply the derivative rule of the first one, I'm going to times that in front, and I'm going to minus 1 from it. I'm going to take this one and I'm going to times that in front, and I'm going to minus 1 from it. And here again, what is here? There's an invisible 1. I'm going to take that and I'm going to times that in front, and I'm going to minus 1 from it. And that's all I do for each one of those. So we end up going 4 times 3, which is 12, x 4 minus 1, which is to the power of 3. 2 times 2 leaves it as a positive 4. 2 minus 1 means that I'm going to have no power. Well, I'm going to have a power there. I'm going to have an invisible 1, right? And then over here, I'm going to have 1, because there's an invisible 1 there, times my minus 5. And I'm going to go 1 minus 1, which ends up being to the power of 0. So this becomes x to the power of 0, which is the same as 1. And 5 times 1 ends up staying as 5. Sorry, let's write that we're doing the derivative of this function. So my answer is 12x cubed plus 4x minus 5. Quite easy. The next example, we've got a half x to the power of negative a quarter minus 6x to the power of a third minus pi. Well, we know that pi, let's get my different color out here, we know that pi is actually a constant, right? What is that constant value? It's 3.14 dot, 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 right? So we know that pi is a constant value, and when we're dealing with constants and we're finding the derivative of them, we know that they equal to 0. And then each of these, this one freaks everybody out, but all you're going to do is take the fraction, times it in front to that fraction, and we're going to minus 1 from that. And then we're going to do the same to this, take that value, times what's in front, let's put a times there, and minus 1 from it. Guys, your calculator can really do most of that work, but try use your mental maths. It really does pick up your game a little bit when you get into exams. You don't have to waste time using a calculator. So firstly, I'm going to write this out slowly just so that you guys can see it. We're going to have minus a quarter, and we're going to times that with a half. And we're going to have x minus a quarter minus 1. Guys, already over here, so that you can not freak out a little bit, remember this is a fraction. So I'm going to have a fraction minus 1. Minusing 1 is quite easy, but you can write 1 as 4 over 4. Okay, makes your life easier over here. Then we end up having minus 6, and we've got to times that by 1 over 3, and we end up having x 1 over 3 minus 1. And again, change that 1 to a 3 over 3. Your calculator can do that, you can plug it in, and then we end up having minus 0 because pi is our constant. So if we go look at this, tops times tops, bottom times bottoms, 1 times 1 is 1 over 2 times 4 is 8, so it becomes a minus 8x. Minus 1 minus 4 gives you minus 5 over 4. They have the same denominator, therefore you just play with the tops. Over here, this is the same as writing minus 6 over 1. And when I've done that, I can see that I can cross simplify. 3 can go into itself once and into minus 6 2 times. Okay, and then we can simplify that. So over here you end up having tops times tops minus 2 times 1, and 1 times 1 leaves you with minus 2. And x ends up being a third minus 3 over 3. So 1 minus 3 leaves you with minus 2 over 3. And that ends up being your rule, your derivative for this function over here. I hope you followed that. If you didn't, rewind, watch it again, and try to do the example without me actually showing you the steps. Okay, looking at examples 3 and 4. Example 3, the function that is given is 2 brackets, x minus 3 and 2x plus 1. Now, I wasn't given a rule to deal with items multiplying together, so I need to simplify this before I can actually derive it, okay? So what I end up doing is I end up saying x times x gives you 2x squared, so I get rid of my brackets. I'm going to have a minus 6x plus x, which gives me a minus 5x, and then a 1 times minus 3 gives me minus 3. Now I have it in terms of a function that I can deal with the rules that I've been given. So I can sit there and go find the derivative of x find the derivative with respect to x, and then we apply our derivative rule here. Let me draw it out. We're going to take the 2, we're going to times it with what is in front, we're going to minus 1 from it. We're going to take this invisible 1, we're going to times it with what's in front of it, and we're going to minus 1 from it. And we know that this 3 ends up just becoming a 0, right? Because it's a constant. So 2 times 2 ends up being 4. X 2 minus 1 is 1. We don't write that 1. 1 times minus 5 is minus 5. We're going to take 1 away from that 1, and it's going to be 0, and anything to the power of 0 is 1. So we're going to times this 5 with 1, which means I can leave that function as is. Not difficult, eh? Remember, you want to simplify these expressions. So over here, I can see that I've got a numerator and a denominator. And I could apply my derivative rule to each one of these separately, but this isn't in its most simplest form. So I need to see if I can simplify this further. Let's try and factorize the top to see if the bottom can eliminate anything at the top. So factors of your first, x times x, easy enough, x times x. We've got a negative sign here, which means a different sign is going to be in each one, a plus and a minus. And we've got our factors of 6. So our factors of 6 are 6 and 1 and 3 and 2. Can 6 and 1 get me to a negative 1 at all by putting a different sign with each of them? Not a chance, no. But if I take that and I put a different sign with each one of those, I can definitely get to negative 1. I want to be on the negative side, so I'm going to have a minus 3 and a plus 2. We're going to put minus 3 plus 2. I did write this question down incorrectly, sorry. Otherwise I cannot simplify. That is supposed to be a plus at the bottom. So we have a plus at the bottom, which means this whole item can now simplify with that whole item. And this whole item, this whole function is now reduced to just simply x minus 3. So if I want to find the derivative of x minus 3, I know that I apply my rules. This is a constant, so that's going to be a big fat 0. This has got an invisible 1 there, times it in front, and we're going to minus 1 from that exponent. So we end up getting 1 times 1 is 1, and x to the power of 0 is the same as writing 1, because that becomes a 1. Are we happy with that? So example 4 wasn't actually too bad, you just had to simplify it down. In the next lesson, we're going to look at our different ways in which we can represent a function and its derivative with the different notations that we deal with. So work through the activities prescribed on your classroom, and I hope that you understood that.